Good morning, 7th grade scholars. Today for ELT, you're doing integer operations, and then you're going to classify real numbers. So if I look at number 1, this is -5 plus -5. So I have 5 negatives here. I have another 5 negatives here. Total, I have 10 negatives. And their sum would be -10. 2, it works the same way. I just have 1 negative this time here, and then I have 1, 2, 3, 4, 5. I have 6 negatives total. Number 3 is a little bit different because this time I have positives, or I'm starting with a positive number, and then I have a negative. When this happens, a positive and a negative are what we call a zero pair. They make 0. And I'm left with 1, 2, 3, 4. Another way to look at that if that's confusing you is I'm starting at +5, and if it's negative, I'm moving to the left one time on the number line. So that would be still be 4. Just remember when you do subtraction, if you see minus a negative, you turn it into a positive. Then I have 1 negative and 3 positives. And that would be 2. A negative and a negative makes a positive like this, so -5 plus 4. Would be a -1. On the next page, you have some quotient. So it says find each quotient. That means you have some division. And then you have some where it says find each product, which would be multiplication. So if I'm finding each quotient, what this means, we already said it meant division. You can use this Dorito chip for this. A negative and a positive is a negative, a -6. This only works if you are multiplying or dividing. So since I'm multiplying down here, I can draw this Dorito chip method again. A negative and a positive are a negative. It would be a -100. When you get to this part, it says name the set or sets to which each number belongs. So this is the real number system. All numbers we see in middle school are real. They can either be rational or irrational. If they're rational, they can be integers or whole numbers. So irrational numbers are decimals that never end or repeat. They're really crazy. Rational numbers are fractions or decimals that end or repeat. So here the irrational numbers would look like 3.1217, like they don't have any order. Here it could be 0.3 repeating. This would be rational. It could be a decimal like -2.5 because the decimal ends or terminates. Integers, guys, could be positive or negative, but they're whole. So they're not whole numbers, but they are not fractions or decimals. So like -3 would be an integer. -10/2, well, that divides to be -5, also be an integer. And then whole numbers have to be positive, cannot be fractions or decimals. So let's look at number 21. Okay, so it's not a fraction or a decimal, but it's negative, so that means this would be an integer. And if it's an integer, it's also inside the rational number set. So it's an integer and it's also rational. Number 24, this is 0. We know that whole numbers start at 0, so 0 is a whole number. But if it's whole, it's also an integer. It's also rational. The next page, Okay, we see a fraction. So you always want to divide your fraction just to make sure you don't get a whole number. Because sometimes there can be whole numbers in disguise. So when I divide it out, I get 1 and 1/15. Definitely not a whole number. It's positive. We would call this a rational number. It can't be a whole number or an integer because it has a fraction part. Okay, last one I'm going to do with y'all, -2 over -2. Oh, that divides to be a positive 1. So if it's positive and there's not a fraction or decimal, it could be whole and integer and rational. So that was just a quick review. Keep doing your ELT. Hope it goes well.